Zach, Austin, Cody, Adam, and Joseph. Okay. I think we should just continue bashing on Starbucks today instead of talking about databases and web.
Oh yeah, Starbucks is terrible. Probably offended everyone in the room.
You get stars if you go there. You get your, I don't know, or try to earn those free drinks. And the free drink is probably watered down too. So it's just wrong. You can mess with a lot of things, but don't mess with people's caffeine. That's not a good thing.
Especially when it's Starbucks thing.
Yeah.
Everything analyzed.
Yeah, you pay
Might
for
as
it.
well get the perfect.
Yep.
We'll get you a drink tomorrow next time.
There we go. I'm already caffeinated, so it's on the screen here. I found this article, and you may just want to look at this on your own if you're interested in this kind of stuff, because we don't talk about it directly in this class, but cybersecurity, another subject that's near and dear to my heart, and then web design, and combining the two. So I found this article, I thought it was quite interesting, talking about how, we need to build in security into web page design. And so it shouldn't be an afterthought, like it's historically been kind of an afterthought. And same thing with or just general applications, not just web applications. A lot of times we tend to go on back and add security features in afterwards, like, oh yeah, we've got this application that works now, but we've really got to have a username and password, so add that on there. So it's kind of an afterthought. So same kind of thing here. But the web is probably the most popular avenue of attack for hackers these days, is to come in and try to attack through web applications and see if they can get to the back end servers, do things. Because their goal, originally hackers were going after things like networks, saying, can I connect to this network? Can I get to can I connect to FalconNet? And can I get a username and password prompt? Now they want to go to the real data sources behind it. So they want to go to the back end databases and try to attack things that way. There are so many users of these applications that the amount of sensitive information stored in them is massive. So that's the real target these days, is the back end information. So just something to think about. I'll try to work in talking about security when it's important, like when we talk about how we protect the user IDs and passwords. We'll talk about that at that point. We'll talk about hiding files and what we can do to make things more secure. But there's some basic things, like checking input, scanning input to make sure it's correct coming into the system. All right, Thursday, we got our test. And the big thing here is that it's going to be online. I had a couple of questions right before class started. So you don't need to be here on Thursday. Woohoo, it's like you got a whole week off next week, and then you got this Thursday, all you gotta do is take a little test. But no, you don't have to be here for class, so we won't be in the classroom. I won't be here. I'll be in my office. But you can take the test anytime. You don't have to take it between 10:05 and 11:20, anything like that. You can just take it anytime during that day. In fact, if I get my act together, I might even open it up like Wednesday night late, and then it'll be available for you on Thursday. And you can take it anytime on Thursday. So if you're a morning person, take it right away in the morning. If you're an evening person, you take it at night, whatever works for you. I'm not really a morning person, but I found out I'm not really a night person either. So I'm just kind of a nothing. I don't know when I hit my peak, maybe like 2 o'clock in the afternoon. That's about it. So it's going to cover chapters 1 through 4 in the book. Chapter 4 should largely be reviewed. Chapter 4 and chapter 5, both of those chapters are mainly things right out of the 430 class, the database class that we had. Talks about just the importance of SQL language as a general language, and then talks about some of the specifics of MySQL. So those should be largely reviewed. So 1 through 3 are really the kind of new material for this class. It's going to be true, false, multiple choice, and a few short answer questions. All right, we're going to continue on. We're going to talk about MySQL and PHP MyAdmin. And every time I say MySQL, I can also just substitute in there MariaDB because they're really similar. And I've got some slides that'll talk about the differences between those two. So by now, this should be second nature to you. You go in, you start up this XAMPP control, and this is the window. This is the Mac version of what it looks like. So it looks a little bit different. But the Windows version looks different than this one. But you got to go in there and start those services up. And for now, we just start up everything, which all 3 services, the FTP client, the database, and the web server, the Apache web server. Technically, we wouldn't probably need to use the FTP server, but we'll get to that point where we're going to be using that down the road. So this is what it looks like roughly in different versions of with the Windows version on the left and the Mac version on the right. You start up those services. Not anything big surprises here. In this particular case, FileZilla was left down, but you can start up the database and you can start up the web server. Doesn't matter. I don't know if anybody's run into this, but sometimes you have a port issue. Sometimes it says like that port, in this case, on the Windows side, it's got port 2036, 5532, 7632. I've had a couple of times in the past where it says that there's a confliction with a different port. That was some other application is using that same port. So all I had to do is change it. So I've just bumped up the number by 1 and it seemed to work. Like, so if it was like 2036, I just made it 2037 and then it seemed to work for me. So we can try something like that first. Oh, thanks, Jack. I will change this. All he's seen is a black screen. I will try to get things fixed up. So now you hopefully can see the PowerPoint slide. Thanks for letting me know. Excellent. All right. For getting into the application, this I should have done earlier. You actually on the Mac side on the right, click on Open Application folder where the little arrow is. And for the Windows one, it's a little more hidden. It's that admin button. You got to click on this little admin button. That takes you to the application, takes you into PHP MyAdmin. You can just go with a browser to http://localhost/php myadmin. So you can always just type that, go to browser, Chrome, Firefox, whatever you want to use, Safari, and just type localhost/php myadmin will take you right into that application if it's up and running. If it doesn't load, then you know your services aren't running. So you got to go back and you got to start the services. So it's either you can go to, there's a number of different ways you can do this, and it's personal choice, whichever one you want to do. Creating a new database in this graphical tool is super simple. You just click on the databases tab, and it comes back with a little box and it says, what do you want to name your database? And then things like what kind of collation you want. And usually we just take the defaults for all these different values. What language do you want it to be in? English? What theme do you want? There's different themes, but like I said, you just take the defaults for all these. You don't need to change those particular settings. And font size. Create a name, like in this case, I've created one. Sorry, it's really hard to see this. DB state capital. And then I click on the create button. So those two steps, and you've just created a brand new database that didn't exist before. So it's that simple to do. You can do this with command line also as well. You can just say create database DB state capitals, and it would create a database for you that way. Click on the new database and check the privileges link. It's a little early. This is a little bit out of order. What you want to do is you want to create some tables first and things like that. But when you create the privileges here, this is where you can create new users as well. So I create a database here, and it says DB state capital, and it says check privileges where the little arrow is on the screen. So I can click on it and I can check the privileges for the database itself. But more than likely what you want to do is you want to create some tables first, add the columns, add some data, then grant permissions to those particular tables. So this is the next logical step, is to adding some users to your database. For the most part, for our stuff, we're going to just use single user databases. You'll be the administrator, you'll be the DBA, and you'll control everything. And we're not going to have a whole bunch of different users. I'm trying to think if we do have any exercise where we actually create some extra users, we might do that in the future. But for the most part, we don't have to do that kind of stuff. But it's as simple as clicking this little add user button. You add a username, and it's going to ask you for a password. And it shows the previously existing users at the top of the screen here, where it says root, root, and root. There's a root one for local host. There's a root for host 127.0.0.1, which is actually localhost as well. And those root accounts have all privileges. They have full DBA rights, so they can do anything they need to the database. Obviously, we need to be a little bit careful if we are creating new users. And this was a production database. We don't want to give new users all privileges, because that's kind of a reserved thing just for DBAs, because you want to protect the data. So in this particular case, it asks you for a username. What username do you want to do now? A lot of businesses are going to have standards, like that they might do first initial, last name, or first name, last name. Sometimes they'll use positions like clerk or SA clerk or something like that. They'll give out different names. But you can name it anything you want to, but you have to follow the company standards if there are standard names. Standard names just make it easier if you go through and you have to look at who's on the system later on and try to figure out who somebody is. It's a standardized name. I'm not a huge fan of doing things like clerk 1, clerk 2, that kind of stuff. Customer service rep. Sometimes we create names like that and we make generic accounts, but shared accounts are potentially a security problem. You can actually specify which host they can get connected to. And this time it's got a percent symbol, which is like a wildcard. And then it asks for password. And you can type in a password. Now, most of the time what would happen is you would create a password and you would make it so that they have to change the password on the first use of it. But the interesting thing here is it actually will come back and it'll warn you if you give a really weak password. So you can type in a single letter password. So I could just type in the letter A for a password. And it'll take it. It comes back with a warning, says, this is a weak password. Are you sure you want to do this? But it lets you do it. So it's just a kind of a warning message that pops up. So you don't necessarily need to do that. So I think it would be nicer if it enforced that, or if at least made it a little more restrictive than what it is. Single letter passwords are going to take a fraction of a second to guess. Even 2 or 3 digit passwords are going to be easy to guess. So you want to have probably 8 or more characters for a password. So if you scroll down on this screen, you're going to see that all the privileges of the database, DB capital, state capital, are pre-selected. Click on go. So what you've got down here is you've got a list of different things: select, insert, update, delete, and file access. And then you've got some other ones. These are more the DBA type privileges: create, alter, index, drop, create temporary tables, show users. So basically what we would typically give is we give users ones from the left-hand column, where we would select certain columns, allow them to insert into some tables, delete, insert. We don't generally give out the structure ones. Those are pretty much reserved for DBAs. And certainly we probably don't give out anything with the administration column as well. That has grant, super, process, reload, shutdown, show database, lock tables. I mean, you don't want to give every user the ability to shut down the database. That would be potentially bad, right? So it's got this little checkbox where the red arrow is. It says grant all privileges on database DB state capital. I would be careful with that one, because that just gives everybody insert, update, delete, and select on every table in the database, which is probably way more than they really need to do their job. So if this was a production database, I would never check that box. That's potentially pretty dangerous. And then one of the things that PHP My Admin does is it has this little go button, and it tends to move around on the screen a little bit, depending on which screen you're on. It's in different locations. Sometimes it's actually scrolled down a little bit, so you have to scroll down the screen to get to it. But you just have to look for that go button and hit that. If you were doing command line stuff, you would just be hitting a return, carriage return, to enter something into the system. All right, so this database, you create the table, it's empty. So in this particular case, for this example, they went out to a Wikipedia page for a list of capitals in the United States. So they're basically creating a table of state capitals, so states and their capitals. So Wisconsin would show Madison. And so you would want to populate this thing. And so if you want to just create a table that looks just like this example from Wikipedia, what you do is you create 10 separate columns: state, abbreviation, date of statehood, capital, capital since for a date, land area, rank in cities by its population, municipal population, metropolitan population, and then notes, those 10 columns. So you would create those. And if you're a DBA and you're creating these tables, you have to decide what data types to make them and what sizes to make them. So in this particular case, I've got this little box on the bottom. Let's say that we use the abbreviation column as the primary key that will uniquely identify each row or record. There are 10 columns. So what we're going to do is we're going to use AL for Alabama, AK for Alaska, AZ for Arizona. And so those are going to be the 50 different states, plus maybe something like DC and Puerto Rico and a few other places that you might add in there. But that's going to be a unique thing. So you have to have a unique key. So we could potentially use abbreviation for that. So we're going to create 10 fields, 10 columns, and we're going to give permission. Field size like varchar 40, or for capital name, maybe 15 or 20 works is sufficient. Variable length character 20. In a little bit, I'll talk about some of the differences between character and variable length character data. Create the table to hold the data. Oh, good question. If you already define the columns and their data types, is there a way that you can pull the data from the Wikipedia state capitals table into database using web scraping or an API? Yes, you can. I'm not sure if there's something specific for Wikipedia for doing that, but you could certainly select that all and create a comma separated list, and you can import it that way. So that's a really popular way of doing things, to just create a comma separated list or some kind of delimited list. You could use semicolons or dashes or backslashes or anything like that, but some kind of way to delimit things. So you would basically copy that and paste it into a file, and then you can import that into the database. You're talking about a little bit more of a direct approach. I'm not sure if something like Wikipedia has an API where you could just extract that and load it directly into the database. That would be really slick if you had that ability. I like that idea. I think initially you'd probably end up having to just go ahead and copy it into and put it into a file and then paste it that way. But yeah, we're going to talk about that today. I'm going to show you an example of a file that I've got. It's an SQL file to create a database, create tables, populate them with data, give permissions. You can do it all in one file. So there are ways to automate this process so that it is much faster and you can do things quickly like that. Oh, good question. We got caffeine and we got participation now. This is good. Well, it's weak caffeine. Start filling in the column names, make the abbreviation the primary key under the index drop down. So when you go over here, it's the top red arrow. It's a little hard to see. Sorry, these screen captures are so hard to see. It's a screen capture of a web page. It's the PHP My Admin tool. But if you go into there, let me see if I can do that once. I should be able to just go there. Host / PHP My Admin. Just try this, see if this works. All right, so hopefully everybody can see this screen. Like if I want to create a new table here, I go up here and I'll just create a table called test 1, number of columns 4, create it. You've got the ability here under index column to make it primary key. So whatever this first column is, I go over here and I'll just call it length values 5. Index, I would say primary key. And what this does is it's going to show you, here's the SQL. It's going to give you the ability to preview this SQL before you type in, before you enter it. But it's going to create a brand new table. It's going to create a primary key. So that's how that works. You select the primary key for state address, state abbreviation, ABBR. And that's going to create that primary key. Every table needs to have a primary key. We talked about that way back in CSC 430, talking about first normal form, getting into normalized forms. Every key needs a primary key. So you, in this case, you pick something that's random. You could use state name. So that's unique. You could use state abbreviation, which is what the authors chose to use. There's potentially other things. You could just have a system assigned number. This is state number 1. This is state number 2. You could go in order that the states were added and just assign them a manually assigned number and do auto increment on it. So there's a number of different ways that you could do the same configuration. Finish entering the columns, enter the appropriate types, and click on Save. So those are the steps you would do. I want to have a state name column. I want to make it character or variable length character. Make it 15 or 20. I don't know what's the longest state name, probably Mississippi or something like that. For number of characters, but you just figure that out and you make it that number. You have to do that for every column. It's a DBA choice, but oftentimes we work with end users on something like this. We don't just make that decision ourselves in a bubble. We work with end users to try to come up with a good-looking table design that's going to work. That's going to hold the data that it needs to. So that's where you have to have a lot of time interviewing end users and saying, what's the data going to look like? Because you may or may not at that point in time be considered an expert in that particular data yet. You'll get there. Once this table is actually created, I've got a new table and it shows on this drop down over on the side over here where it says table state capital. And it's got all of the columns, the data types, varchar 20, character 2, integer 11, etc. A lot of these we don't worry about. Nulls, yes or no. It says no, so it's not going to allow empty columns in that field. It's going to have, everything's going to have to be populated correctly. Then you've got a bunch of these buttons on the right here are not part of the database. They're not part of the table itself. They're not in there. They're just there for convenience. Change, drop, primary, unique, index, spatial, full text, and distinct values are not columns in the table. You've got the little pencil symbol here if you want to edit a particular thing. If you want to change the name of a column or change the data type, you can change it right there. This is getting back to Zach's question a little bit. If you would create a comma separated variable file, CSV file, you could import things into your database this way. And I'll show you an example of that in a few minutes. Yeah, you can do this. You go to the import tab, which is one of the tabs across the top. It's like the fifth or sixth one over. And you click and it says browse. And you can look on your operating system for a file. If you saved a comma separated file out there, you can import that into the database and it'll populate it. These things are really fast. I've done rows of 1 million row tables imported, and it takes just a fraction of a few seconds to do it. It's remarkably quick how fast it loads these things. It does not have to be comma separated variable. You could use other kinds of distinction between it. It detected in this case that you're selecting a state capital.csv file. So it detects automatically. And in this particular case, it comes back and says, oh, you've got a comma separated variable file, but it gives you the ability to do different ones, different ways. If I go to here to the import tab, I don't believe I've got any CSV files. Let me just see if I've got anything in here that would work. No, I don't actually have a file in that format. No. Okay, so I can't actually demonstrate this particular step, but this is where you would go. You'd go to the import page and you would select the file name, and then it would come back and would allow you to import things. And this gives you some other features that you can do. You can control the number of rows that you're going to import. So if you want to just do 10 rows or something like that as a sample, just to see that it works, rather than doing a 10 million row table, you can do that. What format it's going to be. Can be XML as well. There's ways you can actually connect up like Microsoft Excel and other tools using things called ODBC, Open Database Connectivity. So you can connect up something like that. You can import directly that way as well. So that's the import tab. Results of the import is going to come back very, very quickly. In this case, it says import has been successfully finished. 50 queries executed, statecapital.csv. So it tells you the name of the file just to make sure you got the right file. That comes back with the information. And in this case, you've got 50 rows returned, which makes sense because we've got 50 states in the state capital list. So as long as you don't have other things like Puerto Rico or DC, you're cool. 50 works really well. And then it shows you some of the sample rows. Insert into TB state capital values Alabama, comma, AL, comma, 1819, comma, Montgomery, comma, 8. Everything is separated with commas. And so those are the rows that it's inserting into things. So that's actually what the file would look like. If you wanted to create this file on your own, you could do that. You could create a file and actually say in there, insert into this table these values. So you've got that ability to do that. It'll come back with red on the screen. If there's an error, it'll throw an error. It comes back with kind of, it's more of a pink color, but it's definitely noticeable that you've got an error on the screen if it fails for any reason. Maybe you've got something where it just didn't line up correctly. You forgot one comma between one field and another field. So things didn't line up correctly. It'll throw an error on something like that. Obviously, you want to look at the table when you're done just to make sure that it looks correct, that all the data is correct. So scroll through those 50 rows to make sure it looks correct. You can go over to the Browse tab to do that. So you go to the original Browse tab, and that's where you can see the data itself. So I didn't run the script myself, so I can actually show you these tables. But this is what it looks like down on the bottom of the screen. Those particular tables. Again, it's got the rows that are added there. The tools are added just for visually to help us out with things. The edit, copy, and delete buttons are just added. They're not part of the database. So really what it starts with is state name, state abbreviation, state date, capital date, etc. One of the things you notice is that in this particular case, the first column is not the primary key. And that's a little bit unusual. You don't need to do it. There's no hard and fast rule that says column 1 must always be the primary key. In this case, they came up with state name, and that's fine. Because one of the things we talked about in the 430 class is that the order of rows and the order of columns really don't matter. But you can switch this stuff around. So what you can do is you can change things through queries. So you can do order bys, group bys. You can sort ascending or descending order. So you've got full control over this stuff. So really the way it's put in there doesn't really matter, but it's kind of an unwritten convention that typically I'd probably say like 80 and 90% or more of the time I've seen the primary key be in the first column. So in other words, like if we were creating a student table, we'd have our phone number listed as the first column. Doesn't have to be that way. It's not a database requirement, but it's just a standard. If we weren't running XAMPP for this class, what we would probably do is we'd go out and we'd actually install MySQL itself as a database by itself. So if I click on this link here, it's going to go out to here to MySQL website. This is where you would go to get the database itself. And there's a really great tool called MySQL Workbench, which is a lot like PHP MyAdmin. And it has a little bit different interface, but it's really good tool. I've used it quite a bit. So you can install the database that way. You could do things like that. You can install the Workbench tool, and you could do everything with it this way. The problem with this approach is this one doesn't have a web server. And so you're not going to be able to do things like we are with going in and seeing how your web page looks when connecting to the database. This is just a pure database, pure MySQL database. And you can get MariaDB the same way. So this doesn't really meet our needs as giving us a back-end database and giving us the front-end applications where we can have a web server and we can do web pages to connect to a back-end database. There's several different versions of MySQL that are out there. There's like a standalone version, single user, there's multiple user versions, there's enterprise versions. So there's different versions of software that's out there as well. You click on Downloads tab. Pick the edition that you want. And then you would come out here, and this is where you get MySQL Workbench. That's the tool, the interface tool. It's very similar to PHP MyAdmin. A couple of differences exist between MariaDB and MySQL. They're subtle, they're not that bad. Right now, what happened was, this really kind of tells the whole story. MariaDB is a fork of MySQL. What happened was Oracle basically bought and earned the rights to MySQL. This happened several years ago, and people at the time panicked because they thought that this nice open source database called MySQL was going to be taken over by this evil corporate giant called Oracle. And they already had their own database, and either they were going to kill it or they were going to change it and start charging a ridiculous amount of money for it. There were a number of fears and concerns. So what they did is they created a brand new fork using the exact same code and created MariaDB, which was at the time an exact clone of MySQL. Now, since they've drifted a little bit apart, but they're really, really similar. They take really big strides to make sure that they're very compatible with each other. So when we talk about one, you can really talk about the other one. They're pretty much interchangeable. MariaDB is still completely open source, while MySQL now has closed source modules. So there's parts of the MySQL database that Oracle has closed down and they consider proprietary now. MariaDB delivers better performance, is faster and more lightweight than MySQL due to 12 new storage engines and 200,000 plus connections. So they're pretty much interchangeable. I was just talking about, like, do you make the first column your primary key column? That's not necessarily something you need to do. But you can do that. It's convention. And so here's a bunch of other naming conventions that are out there that are typically used. These do not have to be this way. The database is not going to enforce these a particular way. When creating databases and tables, you should come up with names that are clear, meaningful, and easy to type. That's a trade-off right there. If I want to be really lazy, I could create a customer table and just call it cust, C-U-S-T. And that works. It's short, it's convenient, it's easy to type, but it's not very descriptive. So if I want to be a little more verbose, I could create a table called customer information or something like that. That would be a little bit more wordy, but you can do that kind of stuff. So you come up with something that's clear, that's meaningful. You don't want to do too many acronyms because that gets to be a problem. And so many of the tools now are like PHP MyAdmin, where you don't actually have to type the name. It's not like you're going to a command prompt and you're doing select star from this really long name. Well, you got to type out where last name is equal to whatever. So you've got this description so that you can make the table names meaningful enough. Hey, it's a tour, everybody smile. Names should only contain letters, numbers, and underscores, no spaces. You can't name a table, for example, customer space information. You can put it together, you can use camel case, you can use different ways of doing things, but you can't create anything with spaces in it. So names, numbers, and special characters like underscore. should not be the same as an existing keyword. So you cannot create a table called select, for example, or insert or delete or update or alter, any of those reserved words. You can't create a table called table, for example. Should be treated as case sensitive. Cannot be longer than 64 characters. So you want to make sure you have a long name that's descriptive, but not over the top kind of description. Must be unique within its realm. And that just means that it has to be within the table. So a table cannot have two columns with the same name. So I can't have address and address twice in the same table. That's why you'll see address 1 and address 2, is because you can't have two columns with the same name. There's no way to distinguish between them, so it just wouldn't work. So you can't do it that way. You can, however, use the same column in two different tables. So I can have a customer table with address, and I can have a shipping table with address. That's fine. But within the same realm, within that same table, I can't have two that are labeled as address. Oftentimes you want to actually use the same name because you don't want to use address and then ADDR and then ADR and different names of that. Just make it consistent across the database, make it address for everything. If you're talking about a shipping address, a home address, a vendor address, you can just use the term address and use it across the board. This is largely review from what we've had in the 430 class. SQL is a structured query language, which is sort of a universal language that's out there for relational databases. It's a non-procedural language. You specify what needs to be done. So such thing as create a table. So create table customer rather than how it is done. And here's the tricky part on the bottom is several different dialects exist. So Oracle's version of SQL is a little bit different than Sybase's version of SQL, which is a little bit different than SQL Server's version. And it's a little bit different than MariaDB or MySQL. So you have to be aware of that these things differ from database to different database. It's not a big issue. They're like more than 90%, probably 95% compatible, but there are some subtle differences. So for example, in Oracle, they're the only ones with a varchar2 data type. You won't see that in any other database. You'll see varchar, but you won't see varchar2. What happened was Oracle thought they wanted to have this data type and nobody else agreed with it. So they just went ahead and did it because they're the world's largest database company. So we're just going to do it. So they created their own data type. So you just need to be aware of those things that exist out there. The SQL for creating tables, pretty simple. We're going to probably go through things like phpMyAdmin to actually create tables. So we use a graphical interface to do that rather than command line stuff. But the command line stuff is nice to know because the graphical user interface is all it's doing is actually writing that SQL for you. So create table, some table name, and then give it columns. Column 1, and then the data type, and then any kind of constraints on it. Column 2, whatever data type that is, and any kind of constraints on that table, and then keep going. So the constraints are things like, can it be a null field? Is it primary key? Those kind of things. At the very end of it, you'll see on the white part down here, primary key on a particular column or a group of columns. That's where you specify that. For our uses, we're going to just go into phpMyAdmin, we're going to just click a little checkbox that says primary key or a little drop down. Each SQL command must end with a semicolon. That's just a rule that you have to follow. A comma separates all table elements, column, comma, primary key definitions. So between things that's commas, at the end of the statement, it is a semicolon. After you create a bunch of tables, if you're doing command line stuff, you've got some options like shown on the black boxes on the screen here. If I want to see all the tables that are in the database, I can say show tables semicolon, and that comes back with a list of the tables. At a higher level, I can say show databases semicolon, and that lists all the databases. But then I can get into it, I can say use a particular database, use database production semicolon, and then inside there I can say show tables semicolon. That's going to give me a list of tables that's in there. This is all that PHP MyAdmin is really doing anyhow for us, is when it gives us a list of tables on that left-hand column. If I go back into here, when I see these tables that are listed for a database, like here's a database called forum with 3 tables. When it comes back with these tables, forums, messages, and users, all it really is doing behind the scenes is just doing a show tables command, show tables semicolon, and it comes back and gives me a list of those existing tables. So this particular database has 3 tables. And you can see I've got a big selection of different databases out here. Some of these I've created, some of these are system created. So like information schema, performance schema, PHP MyAdmin are all system created when you install the database in the first place. Banking, CSC 460, forum, those are ones that I created. Forum 2, site name, test 1 and test 2 are all created by me. So you got a mix right in there. But this is all this is doing is it's running show tables for you. If I were actually able to look at the query, it would just say show tables semicolon. So I can do show databases, list all the databases in it. And I can say use a particular database. And I can say show tables, that shows me a list of the tables in there. And then I can say describe a table name. So describe space books semicolon comes back with a list of the table. And they do a nice job because it's command line. They do a nice job anyhow formatting this so it looks like some information. So it presents it as a table itself. Comes back with field type, whether it's null or not, key, default values, and then extra information. And it comes back with the ISBN, author, title, and price, and then the data types that they're out there. You can see for these 3, they chose character and then 1 float. But that's just the describe command. You can do that yourself. So if I go back into here and I go into SQL, I can say describe forums. And I click on the go button and it comes back and it says, here's what the forums database table looks like. So I'm already in the forums database. And now I'm looking at this one particular table. And it comes back and it says your query executed successfully. In other words, I didn't have any syntax errors. So it was done correctly. It has the semicolon. And so everything looked good. It's a reserved word. It recognized the word described. The forms table does exist, so it knows that information. So it goes out there and it describes this information, comes back and says form ID, tiny integer 3, unsigned, no nulls, primary key is yes, it is the primary key, and it's got auto increment turned on. So every time I add a new record in here, it's going to be assigned the next available number. And then name varchar 60, not nulls. It is unique. And then there is default value is null, not set. So hopefully you're starting to see that you can do things with either the command line or the graphical tool. It's largely a matter of personal preference. Most people tend to gravitate more towards the graphical tools because they don't have to specifically memorize the different types of SQL commands. But there are some diehards that do SQL all the time. Question? No? Okay. So that's your choice. You can do it either way. But I like the idea that you actually learn the SQL because then you're able to do this kind of stuff. If you ever get to a site that doesn't have a graphical interface, then you're going to be in trouble unless you know the SQL commands. This is just to show you an example of what you could really do here if you wanted to from a command line standpoint. If I'm on my J drive, right, I can say MySQL -H, which is host cuw.edu. So that would be assuming that that's where my database exists, is on that particular server. -U for user, and in this case I say Bob, and -P, and I leave it blank. I could put the password on that line, but that's more of a security risk because then it's actually going into your history file. So it's actually saving that information and it echoes it back to the screen. So if you just do like this, where it says -P, it comes back with the prompt, enter password, and then you have to type in the password and it hides it with asterisks. And then if you notice, my prompt changes to the MySQL prompt with the little greater than symbol. And what I can do then is I can type commands. I'm now in the database. I'm now connected to MySQL. So it is running on top of the command prompt. And then I say use banking. That tells the database, tells the system that I want to use a particular database. Notice the semicolons on there. Show tables gives me a list of tables. And one of them that's going to come back is going to say accounts. And then I can say the word describe accounts, which is going to give me the structure of the table. It's not going to show me the data. If I wanted to see the data, I'd have to do select star from accounts. In this case, I want to just see the structure. So I say describe space accounts. Deleting tables. There's two ways to delete. There's a delete command or there's drop. Drop is slightly more powerful. Delete, I can say delete from customers where last name is equal to Jones. And it's going to go through and it's going to remove all the records for customers that are Jones. If I say delete from customers, it's going to delete all rows, but it's going to leave the table out there. Drop is a little more powerful. If I say drop table customers, that gets rid of all the data, but it also gets rid of the table itself. The structure of the table is gone. So with a delete, if I say delete from customers, I end up with an empty table, but I've still got the table out there. If I say drop table customers, it gets rid of the data, but it also gets rid of the table itself. That may be what you want, but you just got to be aware of the differences between the two, because it's, you have to be careful you're not deleting or dropping more than you really want to get rid of. Obviously, it helps to have a good solid backup in place before you do any of these commands. But drop table name, it's like drop table customers. The warning at the bottom of the screen here, this command deletes all the rows in the table name and the table name itself and the table itself. So it's going to do both. That's why usually DBAs or maybe some senior developers are the only ones that can actually do a drop. And if it's in production, it's probably only the DBAs that can do a drop, just because of the power and the danger of doing that stuff. Like we're working on the roof leaks, or there's maybe a herd of elephants up on the roof. We got some. You can see the tile in the back, way in the back corner. We had a pretty massive leak in this place the other day. One tile is just half hanging down. It was all raining on top of the printers, which is great because you have these nice 3D printers and it's dripping in on them. Don't get me started on this, but a little aside, I'm just concerned because we're doing a whole lot more renovations to the department next summer. They're going to do more changes, more flooring, more walls. They're going to shift things around. They're going to cut some windows into the hallway, all kinds of big changes. But I keep saying, well, are we going to fix the roof? Because, putting in all new lights and new ceilings and new floors and new desks, it's going to look nice. But then as soon as we get the first snowstorm or rainstorm, it's going to be bad. So I'll step off my bandwagon now. I'm done. All right. Adding table rows. This is something that's really commonly done. And in fact, if you go to Amazon and you place an order for something, it's actually adding you into the orders table. So this is kind of what it does. It does an insert. So behind the scenes on any tool, no matter how fancy the graphical tool is, or it's a web page that's doing this kind of stuff, it is just doing a simple insert into a database. So somebody somewhere in the software had actually write insert into table name values, value 1, comma, value 2 up to value n, semicolon. So the insert table is a powerful tool. Most of the time, people will be given the ability to do insert more likely than there are the ability to do updates or deletes. Deletes are the ones that are generally people are the most careful with, because delete is a powerful command. Update can also change multiple rows, so you have to be a little bit careful with that one, with who you give that one to. Insert is not such a terrible thing unless it's a security thing, like you don't want somebody to insert something into a table, but otherwise insert's not going to get you in as much trouble as a delete or an update statement would be able to do. Insert adds one row or a tuple, a single row at a time, into a table. Requires a value to be specified for every column. So you've got to say value 1, comma, value 2, comma, value 3. In fact, if you don't specifically fill in every single column, then you've got to specify which column name it is and then have a matching value that goes into that column. If you're going to fill in every single column, then you can do it just like this part that shows in yellow on the screen, where you just say insert into a table name, a bunch of values. Here's the script I wanted to show you, SQL.SQL. It's a cleverly named script, SQL.SQL. Couple of things here. It doesn't insert into the users table. So let me show you what this looks like. All right. So I go up here, and here it is, SQL.SQL. Sorry, this is a little hard to see at the very top. It's got comments, and all the comments are grayed out, which is kind of a good way to do this. So it means that these are not going to be executed. And it's nice that the author included a bunch of comments into this particular script, but it's just hard to see with this tool called brackets. Let's see if I can make this a little bit bigger. There we go. So hopefully you can see this. This is a script that's going to be used in chapter 5. So when we get to the next chapter, we'll use this particular script. But what this does is it goes out there and it's going to create a bunch of things for us and populate them. So I just wanted to show this to you as an example, because what you can do is you can automate all this stuff. You don't have to do stuff sitting from a command line, typing a bunch of stuff one at a time. You don't have to go into a graphical tool like PHP MyAdmin and enter 2 rows at a time. You can do it in a script. And this is by far the fastest way to do this kind of stuff. So if you look at this on line 15 is where it really starts. The very first thing he does is create a database called site name. And I ran this script already on my database. That's why you'll see that I've got this table out there that it exists already. And then the next line he says is use something. So I create a brand new database and I want to make sure I use it. So I'm telling the database, hey, I now want to use this new database that I just created and basically put me into that database. Then on line 19, create a table called users. And then he's got the next 6 lines are all the columns and the data types that are going into that thing. And then the special constraints, the properties of those columns. It's making user ID a medium int, it's unsigned, not null, and it can be auto incremented. And at the very end on line 26, he says, let's make that user ID the primary key. That's the last thing you do when you create a table, is to make something the primary key. That's just the syntax for it. But then right away, what he does is he starts to insert values into this. This is an all-in-one script. It's creating the database. It's creating the table. It's populating the table with values. So on 29, he starts to insert some records in there. Insert first name, insert into users, first name, last name, email, password, registration date. And then the values clause. And so what it's going to do is it's going to take the very first one, Larry, and it's going to put that in first name. It's positional. That's going to take the very next one, Ullman, and put that into last name. Everything else in this is pretty standard, except for a couple of different things. On the one part down here where it says now, that's a system function. It says, what's the system clock say right now? Use that date and time for today's date and time when I'm inserting this record. And the other thing that's weird is he calls this function called SHA2, mypass, and 512 is the key length for it. SHA2 is a built-in function to do encryption. So what he's saying is, I want to load this into the database, but I don't want it to be readable by anybody, including DBAs. Because for years, DBAs could see everything that went into the database. And so this is a little bit of a safety check, is what he's doing is he's encrypting this. Now here it actually says the word mypass. So the password is visible in this script, but not everybody's going to have access to this script. What this is going to do is it's going to scramble it with a 512-bit key, and it's going to encrypt it and put it into the database that way. And I'll show you what it looks like in a second. Insert into users value Mojito for the password. And then he does an interesting one here on line 36, insert into users the following fields. And he does it as a group. He puts in the 4 Beatles. And then he goes and he puts in a bunch of other singers, performers. Then he does a change on line 64. He says, oh, I want to change the password. I'm sorry, the email address. Maybe I got it wrong. For Mike, it had up here michael@authors.com. And he says, whoops, that was a mistake. I want to change that. So it really should be mike@authors.com. So he does an update statement. And then he decides to delete record number 8, user ID 8. And so what would happen is user number 8, 1, 2, 3, 4, 5, 6, 7, 8, Peter Tork is going to be deleted. And the thing that he does that is brilliant, and this is a great safety check to do, is he says limit 1 on there. So it's only going to delete 1 record. You don't have to worry about having a runaway query that's going to delete 1,000,000 rows or 100,000 rows or even 20 rows. It's going to only delete 1 row. So even if you get that wrong, it's only going to damage 1 row. It's not going to do more than that. So that's really a good use of the word limit on there. Limit space 1 is going to make sure that it doesn't do more rows than what you really thought it was going to do. So I highly recommend doing something like that if you're writing SQL, is to go in there and write a limit clause like that. Then he goes and creates a new table called forum, a new database called forum, sorry. And he uses it, creates a table called forums, which I'm not a big fan of calling the database forum and the tables forums. Another table called messages. Another table called users. And then he inserts a bunch of rows. Does a couple of selects, like he's checking to see that things really worked correctly, to get the feedback. It's going to come back and show the rows that are in that table. Then he does a few inserts. And instead of using now this time, he's using UTC underscore timestamp, which is another way to do things, to get the date and time. So you can see this is a giant file. And this goes through for basically for every chapter of the book. That's going to create a database and then associated tables for every one of these things. But that's all in one script. Think about how powerful this is. I could put this out on Blackboard. You guys could each run this thing, and you each had have every single table that's used in the book, and every single user ID, and every single password. So let me go back up to the top. And I want to go into my database for a second. And here I want to look at this users table. Let me go to I'm going to go to this one. I'm going to go to this version down here. Site name users. This is the first part of the script. It created a database called site name, and then it populated with data. I remember the password was my pass or mojito. And so what it did is it scrambled it. So now if I look at the passwords here, it's this giant string right here. 1C57 3D Feb, whatever it is. Okay. That's through that SHA2 function. So that function scrambles the password. So now if I'm a DBA and I look at everything, I can't see what your password is. I just see this number, right? If you mess up your password and you forget what it is, I can go in there, I can reset it. I can say, okay, now your password today is CUW, and then you got to change it again. But when you change it, it's going to come back with another encrypted value. And so if I put this into my screens and my functions, it's going to come back and it's always going to have an encrypted password. So that's really good for security. So that's the SHA1 or SHA2 function. There's a bunch of those different functions that are out there to do that stuff. So take SHA1 or SHA2, my pass, and then how many bits, 160 bits, or in his example, he used 512 bits to encrypt the password. And the other thing I mentioned was now, or UTC underscore timestamp, to get a date and time. So this is when the record went into the database. Here's a couple of examples of the insert command. Inserting the customer's values 1, Julie Smith, 25 Oak Street, Airport West. Insert in the orders values null, 1, 49.99, and then the date, 2007-4/15. Notice that for the 49.19, 49.99, it doesn't put in dollar signs. It just puts in the value of the amount. The dollar sign can be added on display purposes for later on, when we go out to show that particular row. The row contents are delimited by parentheses. Attribute entities are separated by commas. So field number 1, a value, comma, field number 2, a comma, field number 3, comma. String and date values must be quoted with single quotes or double quotes, either one, personal preference, unless your string actually has a single quote in it. Like if it's a last name like O'Donnell, you have to have double quotes around that so that it puts in that single quote actually into the database itself. Numerical entries are not enclosed in any special characters. So here's an example of a simple one. Insert into users values null. I'm doing auto increment. I want that field to be added automatically, comma, wall, comma, Robert, comma, rwall at cuw.edu, SHA1 or SHA2 function for my password, just being the word secret, and then now. So what that's going to do is it's going to hash the password. So it's not readable by others. This is really review here. Select star from some table. Select star from customers. Right, there shouldn't be any surprises here. Select column name from table name. Select the last name from orders. Here's an example. Select name, comma, city from customers, semicolon. It's going to come back with the list shown on the bottom of the screen. So this is like it's done through a command line. If I now do a select star from users after I ran that SQL.SQL script that the author put out there, it's going to have values in there. It's going to have everything populated in that table. Asterisk is a wildcard character. Select star from users is kind of a lazy way of doing things, and it's not the best from a performance standpoint. So if we really get concerned with performance of our database, we don't want to do that. We want to select just specific column itself. So the bottom one is a little better from a performance standpoint. Select user ID, comma, username from users. You can limit the data selected by placing conditional restrictions in a where clause. So this is review as well. Select something from customers where last name is equal to Anderson. Select column name from table name where condition is listed. So some features. And always has to be ending with a semicolon. This will retrieve all the rows that match the condition. So wherever last name is equal to Anderson, it'll come back with one or more rows. None, it can come back with no rows if there are no Andersons in the database, but it's going to come back with one or more rows if they do exist. You'll get 0 rows returned, which is not an error message. It sometimes looks that way. It'll say no rows returned. That's a good thing in some cases. That just means that it doesn't exist in a database. The answer to your query is that there's no records, or it'll come back and it'll say 0 rows returned. Those are good things. Select title from books where price is greater than $40. So you can use conditionals in there. You've got equal signs, not equal to signs, less than, greater than or equal to, less than or equal to. And so the bottom example, you can also compare it to null. Select star or select name from customers where address is null. So that would give me a list of maybe things in my database that are in error. There's some reason I should have that populated. And so if I want to see rows where it is not populated, I can say select name from customers where address is null. And there's a wildcard. You can do the percent symbol. Select title from books where price is greater than 40 and author is like Thomas percent. What that's going to do is it's going to give me any authors where the first name is Thomas and then the last name is anything. So I might return multiple rows. I might return 0 rows or 1 or more rows with this kind of a query. You can also use not or not like Thomas percent. That's going to do the opposite of that. All right, we are out of time. But what's happening on Thursday? Test, yes. Test online, so you don't have to be here. I will be watching emails. So if you do have any questions, you can send me them. I will be checking that and making sure. My other goal is to get caught up on some grading. Yeah.